The I-70 road cut was exposed in 1971 when I-70 was being constructed. The rocks represent approximately 45 million years of geological time. When each of these layers were deposited 95 to 140 million years ago, Colorado was a warm and tropical place where dinosaurs roamed. Its physical features include broad, flat river valleys that are sometimes exposed to seaway. About 70 million years ago, the Rocky Mountains uplifted and the rock layers tilted upward. The rate of uplift just kept increasing and increasing. This caused the sedimentary layers to almost go horizontal. The place we field tripped at is one of the best visible spots for seeing these uplifted deposits known as the hogback. The west half of the exposure is the Morrison Formation, or Upper Jurassic, while the east half is the Dakota Group, or Cretaceous, consisting of the Lydell and South Platte formations. At the very, very right, although not well exposed in this cut, would be the Benton Formation.
Welcome to the road cut! So how long does it take to deposit each layer? Well, here at the road cut, it took about 45 million years to form this entire area, and it's about, each one's about 213 meters thick, and also, if we take average rate, it's about 210,000 years to form each layer. Now, there are instances where the rate of flow of sediment deposition could slow down, speed up, or stop, which kind of creates error in measuring the amount of time for each layer. And also, there are these things called unconformities. And unconformities are basically areas in rock layers that have been eroded away that create gaps in geologic time. Now, that makes it really difficult for geologists, especially to take the time it takes, measure the time it takes for each layer to be formed.
So why do rocks form layers? Rocks form layers when the stream water spills over the side of the current. When it spills over the side, the stream loses its carrying power. When the stream loses its carrying power, smaller sediments like silt and clay will stay suspended in the water, whereas the heavier segments will drop to the bottom.
So what is a formation? Formation is basically rock that's defined by geologists as that has its own distinct physical features and composition to its own distinct geologic time period. These formations could be traced over long distances on a map, and it's the basic unit a geologist uses to link distinct periods in geologic time together. And there's also, formations can create groups. There's actually 3 formations here at the site that are pretty distinct, and 2 of them create an actual group.
The rocks in the road cut are made out of mineral grains. Some can be seen like sand on a beach, where others are less visible to the naked eye, such as the clay or the silt. There are others that can be seen like ribs in the road cut that are made out of dense limestone. However, all that the rocks have in common is that they all came to rest in floodplains from rivers, streams, or shores of a lake or sea.
So right now we're at the Morrison Formation, and to the left over here there is red, gray, green, and maroon layers of limestone and sandstone, also mudstone as well. And this is evidence to being in the late Jurassic period, about 135 to 140 million years ago. This area used to be an arid lowland with meandering streams, rivers, and lakes. And sometimes these rivers created new forces which built up sediment over time. And inside the sediment, there's actually been fossils found, which were found in the sedimentary rocks. And this layer is actually named after a town called Morrison, just by Red Rocks, just close to here. So right here is the Lydell and South Platte Formation. As you can see here, the left and right are tan and yellow color, which were separated by a berry-colored shale bed. About 135 to 95 million years ago, there have been fossils found from that time period, from the early Cretaceous period. And what happened during that time was on the lower layers, so as you can see over here, it was deposited on top of the Morrison Formation by streams, and after that there was a great sea that moved in from the west, which deposited sand and mud, and that sand and mud created the upper layers. There's contact right between the Morrison Formation and the Lydell and South Platte Formation right here. So this area is called Black Rock. It's given that name mistakenly for looking like a coal bed, but actually it's just clay sheets that is composed of small divided amounts of carbon from dead and plant remains, which gives it this kind of black color. But it's not even that much. Real coal beds contain 100% of dead plant remains. You can also see here, you can't really see it without a magnifying glass, but there's pyrite that is contained in here, which kind of gives it a little shimmer in the light. And also there's this area, when you come here during the day on a immediately calm day, it will smell like sulfur. And you're like, what? How can this smell like sulfur? It's not sulfur. However, there's gypsum that's contained in here, which can give it this odor, because the gypsum gets sweat out along with water, which evaporates, giving it a musty smell. So, the Dakota Group is one of the most valuable sets of sedimentary formations in the Rocky Mountains due to its source of groundwater for primarily irrigation, and also it accounts for nearly 1/3 of the oil and gas production here in Colorado. As you can see here, it's not really a good place to see these oil and gas and irrigation areas, but you can see relatively good clay beds. The light and dark laminations indicate there's a carbonous matter preserved in these clay layers. In history, there have been miners that have come here to use the clay material to create ceramics and pots.
Rocks are colored here because of mineral rust. Mineral rust is caused by the exposure to sun, water, and air. When mineral rust happens, it forms iron oxide. Iron oxides form different colors such as the oranges, the yellows, and even some browns. It forms in a very thin layer that covers the white or even colorless rocks. In some cases, you can find a green hue, which is caused when there's no exposure to oxygen, which can happen in cases like swamps or underwater. As you can see here, this set of rocks is slanted and this set of rocks is horizontal, and they lean up against each other. This is called crossbedding. Crossbedding is caused during the deposition onto bedrock of a tilted surface, such as dunes or ripples. As you can see here, once these rocks hardened, they were tipped up from the west, and these rocks sit horizontal.